Okay, great. Hi, all. Thanks for joining today's webinar. Kim Eli, who is one of the ESS-DIVE partner projects, who's focusing on ESS-DIVE data curation support, will be leading this webinar, which will focus on serving project data legacy with ESS-DIVE. And I will be recording this meeting, and after the meeting, we will share the presentation slides along with the recording on our website. And yeah, Kim, I think we can go ahead and get started. So feel free to share your screen.
Okay, thanks, Dylan. How does that look?
That looks great.
Excellent. All right. Well, thanks for the introduction, and thanks to the ESS-DIVE team for helping me prepare this presentation and gather together some of the materials. So I guess I'm just going to start by giving a little overview of what is this webinar about and who is it for. It's really for any ESS-DIVE users, from big project managers through to individuals who are interested in uploading their data. I'm going to be reviewing some ESS-DIVE features and really focusing on how they can be leveraged to maximize the value of your project data. Moving towards AI data is a really important part of this. And this presentation, I'm going to include a whole bunch of links to resources, so you can come back to these slides and utilize those. I'm going to look at some checklists, some workflows that can be used to manage data publication throughout the project lifestyle. And towards the end of the presentation, look at some special cases such as archiving large data, archiving data developed as part of a GitHub workflow, and what to do with any remaining unpublished data. As you get towards an end of a project, often there's little bits and pieces of data that have been collected that have never been utilized in a publication, but it's still worth getting those on the archive. So part of the value of ESS-DIVE is looking at how ESS-DIVE has been certified as a CoreTrustSeal repository, and what does that mean? Going to again look at features that enable leveraging of AI-ready data, and how project portals can be used to preserve additional resources from any data project, such as what would have been displayed on websites. And finishing off again with looking at considerations for completing final data submission and publication, and how those data workflows might work for you. So I'm going to start with why archive on ESS-DIVE. And this will be familiar to a lot of people, but ESS-DIVE is the DOE's data repository for the ESS program, and it has a mission to provide long-term preservation, broad accessibility, and improved usability of ESS data. ESS-DIVE follows FAIR principles to make the data findable, accessible, interoperable, and reusable, and also the trust principles for transparency, reproducibility, user focus, sustainability, and technology. And I will just note that using ESS-DIVE is actually mandatory for ESS project data. So I'm just going to review a little bit of what it means to be a CoreTrustSeal certified data archive. CoreTrustSeal is an international community-based NGO nonprofit which promotes sustainable and trustworthy data infrastructures. The CoreTrustSeal organization has established a list of requirements for data repositories that meet standards for data integrity and preservation, data quality, discovery and reuse, and security. So to receive a certification, a repository must submit a report demonstrating how these requirements are met. This is then peer-reviewed before certification is given. An important aspect of this is the commitment and mechanisms to provide continuity of access and preservation to data that extends beyond any single project or institution. And to meet this, ESS-DIVE has a data preservation plan, which there will be a link to that in this slide deck. And if you're interested in more details on how ESS-DIVE met these requirements, there's a link here to the document that lays all that out. So to meet CoreTrustSeal requirements, there's 16 specific requirements that fall under the general topics of organizational infrastructure, digital object management, and information technology and security. And I'm just going to focus on 2 of these, which are the requirements per continuity of service and preservation plans, which are in italics at the top of this slide. And meeting these requirements highlights that ESS-DIVE is a stable system for long-term data accessibility. And it has a comprehensive backup system, a data preservation plan, and additional redundancy with replication of all of the data across the Data One network. So at a minimum, this CoreTrustSeal certification guarantees the data continues to be available beyond the lifetime of the project award. So why put your data on ESS-DIVE and not elsewhere? There's a whole list of features that, as a certified repository, ESS-DIVE offers to data users, and they include long-term security, provision of DOIs and data provenance, a well-described metadata system, provision of standard formats that are available to use, options for large data storage, and also versioning systems. Other locations where people sometimes put their data don't offer all of these features, and these include places like Google Drive and GitHub, Zenodo, and the very, traditional way that data used to be preserved in journal supplements. One thing that ESS-DIVE offers is it makes it really simple to cite data sets. You can copy the formatted citation using the citation button on the landing page for a data set, and that will give you a ready to cut and paste data citation. You can also use the DOI that is included on the landing page. And ESS-DIVE data citations are also available in reference management systems like PaperPile. So you can just paste in this DOI, just the number part, not the DOI part or the complete address. And as a certified repository, ESS-DIVE should be an acceptable repository for journals. If you happen to encounter any issues with this, do contact ESS-DIVE. So in terms of the capacity of ESS-DIVE to maximize the value of your data and support AI-ready data, this includes aspects like the standards that have been developed by the community and are aimed at creating well-curated data, the use of ESS-DIVE reporting formats, and the principles of fair and trust. In addition, ESS-DIVE has developed capabilities for easy data discovery and reuse and integration. And some of these include tools like the Fusion database, advanced search features, the Basin 3D, and Jupyter workspaces, and newly developed, and this is an ongoing project, some AI-enabled discovery services. Using ESS-DIVE reporting formats has a number of benefits. From a project point of view, it makes your own data more reusable within your own project. Data that use reporting formats are easy to read, easy to pass, and contain more descriptive information. And for example, if someone on your project collected some soil respiration data one field season and someone else collects it the next field season, if you use the reporting formats, you'll know that the data is already harmonized and will be more easily brought together into analyses. And use of reporting formats reduces the need for decision making. And on top of that, ESS-DIVE has tools designed to parse the formats. And if we can accurately describe file content and header rows, which is using the CSV and file level metadata formats, then we can enable data search and visualization of data within individual files. We have a parser and an API that can search, open, and read files that are available on ESS-DIVE called the Deep Dive API. Here is just a list of currently available reporting formats on ESS-DIVE. A number of these have been recently reviewed to improve their usability and interoperability. So if you haven't looked for a while, I encourage you to go back and have another look. If you're not sure what formats are suitable for your project, there's a really useful reporting format checklist or cheat sheet that has been developed that guides you through what the different formats are and provides direct links to instructions on how to use them. So switching gears now to using data portals as a way of preserving your project identity for projects that are closing out, or active projects as well. So data portals are a really great way of accessing all of the publicly available project data via a single URL. This is something that can be shared, posted on websites to expand access to your data. These portals, both the data content and additional descriptive files, are preserved long-term as part of the whole ESS-DIVE system, and they'll persist into the future beyond any individual project's lifespan. So if you have, say, a project web page that won't be maintained beyond the life of a project, you can mirror the content onto a data portal page, and this will be preserved and allow you to keep information such as the project's objectives and scopes and organizational structure. Portals are also useful as a way to manage project data sets for whole project managers, because you can access, it's just a convenient way of accessing all the data sets that are linked with that project. Here's just some examples of the different aspects of data portals. One thing that they enable you to do is create descriptive web pages, and this is all very flexible space that you can put basically any content that you like on these pages, including images, text, any sort of web content. Portals also have the feature of having automatically generated metrics that describe project's data and can be used for project reporting. Here's an example of the type of metrics that are produced automatically in a portal. So number of data sets, the volume of data, recently updated dates, the types of files, the years across data collection period, and view, downloads, and citation metrics. And these metrics are all automatically updated if you add new data files to your portal. You can link directly to portal metrics using a URL, and this is the kind of thing that can easily be added to any sort of reporting that you do for your project. So now I'm going to go through some typical data archive workflows, starting with a basic workflow of how you might approach just uploading a single data set, and then looking at some special cases for including considerations for projects that are closing out, and how to handle large data or data generated as part of a GitHub workflow. So this slide presents just a basic outline of preparation required before starting a new data submission and a bunch of links to help you get started. I guess I'll note that while using reporting formats and creating metadata can seem time-consuming initially, a lot of it is kind of a bit of a lift at the start of the project, and then as you get going, you can really be efficient in reusing those materials, and it saves a lot of time and headaches. Ideally, projects should create a culture of regularly archiving data as it's produced. This can help prevent data and knowledge loss, particularly associated with staff turnover. For example, if you have students collecting data, it's great to have them be involved in the archive of those data sets as part of their work. This both ensures accurate attribution of the work to those authors and is a really great way of introducing concepts of metadata and data quality, particularly if that's new to those individuals. So in getting started, you sort of think about what data do you need to archive and who are the authors for that data set. A typical data preparation workflow is to gather the data and the metadata. At this point, it would be useful to review the reporting format checklist and decide what reporting formats you would like to use, and then complete a process of any data QC and processing that is required. And here I have included some links to the most basic reporting format types. That's the package metadata format, where there's an offline template that's really useful way of working collaboratively with your data team to create that content before you actually go to the ESS-DIVE and start the actual submission. And another part of that is using reporting format keywords as part of your package metadata. And while the list of reporting formats can be perhaps a little like overwhelming because there are a lot, but many of them are subject specific, and so they're not all relevant to all data types. But if you need to prioritize, start with the file level metadata. This completion of this metadata file, it's just a single CSV file per whole data set, allows ingestion of the files into the Fusion database and is also useful from a data user point of view as a human readable file that describes the content of your data set. So that's definitely one to prioritize. Using the CSV reporting format and following the suggestions for quality CSV files also adds a lot of value to data sets, enables machine readability of those CSV files, and inclusion of data description files that list all your data variables and provide units and descriptions for each of those is, I find, really useful from both a machine readability and a human readability and understanding of the data set point of view. So during the mid phase of a project lifecycle, many researchers might be focused on publishing kind of discrete data sets in support of individual publications. But as a project draws to a concluding phase, it can often be more effective to combine data into larger sort of themed data sets. This could be themed around data types from multiple locations or multiple data types from any location within the project. And just the combination of different data types into a larger data set can just reduce the workload of producing metadata. Something else to consider is staff turnover and how that might affect the access to information by people who are doing the data archiving process. So it's definitely recommended to keep a track of who is responsible for what and try and make sure that all the important information is captured before people leave the project. And definitely, if future contact with those people might be required, it's really useful to obtain other contact details, as often people's institutional phone or email contacts get cut off straight away when they leave. And a really good way of maintaining continuous identifiers for authors in particular is to make sure that everyone obtains an ORC ID, and this is recorded as part of the author information in the ESS-DIVE metadata. And probably one of the most important things is start planning for this process early. Finishing up, everything always takes longer than you expect, unfortunately. So to close out a project might be take several months for a short-term project, but potentially years for larger projects. So this is really quite a substantial process that requires planning. So just going back to what to do with those sort of what is sometimes called legacy data, data that hasn't been published as part of a paper, but it was still something that should be included on ESS-DIVE as data that was collected as part of the project. So the easiest way to deal with this is to wrap it up into larger data sets that combine different data types or perhaps different locations or anything, the common thing being that is part of that project. Here is an example from an early phase of an SFA that includes multiple different data types collected over quite a long time period. And it's totally fine to bundle all that data into a single data set to archive on ESS-DIVE. Another thing to think about is what to do with large data. And this takes a little bit more time to consider than other smaller types of data sets. One thing that needs to have a little bit of thought put into it is what is worth archiving? And one way of thinking about that is thinking about what products will or could be used in the future. A permanent record of every model run or every processing step in dealing with a large data set is not necessarily required for archive. And as I mentioned, don't leave large data archival to the last minute. There's some additional steps in the publication process that are required and some extra kind of handling upload steps to handle those large files. So it takes a little bit more time to go through the publication process. And just some examples of what might be large data include genomics, model outputs, remote sensing data, and large sensor networks. And just to define what large data is, it includes anything that meets any of these requirements, criteria. So any single file that's over 10 gigabytes is considered large data, and that exceeds the limit that can be uploaded using the user interface web page or the API. Any data set that has a combined data volume of over 500 gigabytes is large data, or anything with more than 100 individual files. And so the way that you can upload data depends on the volume of the data. So the web form and the API are limited to maximum size for individual files of 10 gigabytes. You can use those systems for uploading more than 10 gigabytes as long as the individual files do not exceed that size. But then for any of the larger data collections that meet these large data definitions. The Globus transfer service is the way to go in terms of transferring data files to ESS-DIVE for those large data sets. The data submission web form can still be used to upload the metadata, but the files can't be transferred that way. And just some images of how the options for upload and storage of large data. So the one on the left is a screenshot of what the Globus system looks like, and it's actually a really easy desktop kind of software where you can just drag and drop files and start a transfer process, but then has a background process that ensures transfer of the files without corruption or interruption. And for storage of large data and access to hierarchical data, ESS-DIVE has a system called Tier 2, which is kind of something that's linked out of the main web interface from ESS-DIVE, but enables storage of very large data sets and also preservation of folder hierarchies.
Oh, just a second, Kim. We had a question in the chat.
Oh,
Wasn't
yeah.
sure. And we have Shreyas here in the Zoom, so feel free to jump in. But the question is, what's the largest data volume that ESS-DIVE can accept?
Yeah, hi. So we don't have hard limits, but I'd say once you get into the multi-terabyte range, we would encourage you to come talk to us and we can figure out if if the data that you're planning on archiving is actually like makes sense to archive versus like some of it is that's not actually that should just be data that you store somewhere but is not like that's not the published data. So I think we would probably just want to have a conversation with you once you get into the many terabyte range and discuss that. Like, yeah, we don't have any sort of a formally posted limits, but we probably sort of have a conversation about that.
Thanks, Shreyas. Yeah.
There are limits, like I guess, and in terms of individual files, I mean, I think you probably don't want your files over a certain size because then it just becomes really unwieldy to download. So we may advise you to break things up into smaller files.
Yeah, that's a good point. Something that I've considered a little bit in my own work is who your audience is and potential data users, and if they're not, if they perhaps don't have access to like super fast, super high bandwidth internet, you might want to consider structuring your data set in a way that people will be able to access and download just the parts of the data set they need in like smaller, more obtainable segments. So I'll move on now to the last part of this presentation, which is details on how any work developed in GitHub should be archived on ESS-DIVE. So, using scripted workflows on version control systems like Git is becoming an increasingly common practice and is a kind of really nice way of ensuring data reproducibility. But it should be noted that GitHub itself is not a data repository. So your data and your scripts should still be archived on ESS-DIVE. And ESS-DIVE has a standard way of archiving products developed on GitHub. Although just point out that this is for scripts and data, it's not for software that will be licensed. That is something that is not stored on ESS-DIVE. And shown in this slide is just an example of a project that was developed in GitHub and is archived on ESS-DIVE. So there's two components to this. The first is what you do on the GitHub side of your project. And so on GitHub, you should tag your code at the time of publication. And then select a license. The GitHub repo should clearly state the usage license for your code, and it must be one of the licenses that is used by ESS-DIVE, for example, CC by 4. You can't have conflicting licenses between GitHub and ESS-DIVE. And then the last step is citing the ESS-DIVE publication in the GitHub README. And then on the ESS-DIVE side, you upload a complete copy of your GitHub files and add GitHub as the GitHub repository, the tagged version as an external link, as shown in this figure. I'm not sure if you can see my mouse, but the bottom of this image shows the external links section of the ESS-DIVE landing page. And that should be used with a copy of descriptor. And then in the metadata for your data set, you should describe what is contained in the repository and the files and how that is linked with the GitHub repository. So just coming to the kind of key takeaways of this presentation, ESS-DIVE is a secure repository to preserve your project's data legacy, and also using the portals, you can save additional content that might have been on websites or other project materials. Using ESS-DIVE reporting formats makes your data more fair, and that makes it findable, accessible, interoperable, and reusable. And it allows leverage of some of the advanced archive features that ESS-DIVE is offering and is continuing to develop based on using those reporting formats. However, if you're short on time, start with the file level metadata. That gives sort of best bang for your buck, if you like. It's really important to plan ahead, particularly if you're got large data, and as Shreyas commented, sort of the bigger the data set, the more important it is to get in touch and discuss what your data needs might be. And perfection is the enemy of good. There's a point here where just starting with the basics and getting your data uploaded is definitely better than not doing it at all. So thanks for joining this webinar today. There's a whole lot of resources on ESS-DIVE to support your data archive needs. And the support team is available to assist with data submission side using the support email or the contact form on the website. The data curation support before you get to the submission process, I'm available to help people out with that, and that includes things like data set kind of content and structure and how to use reporting formats and other aspects like that. And that can be arranged by using the contact form on the website as well. And I guess now we have time for any further questions and discussion. Thank you.
Okay, so I see we have another question in the chat. This one is asking, how long is the longest period that data can live on ESS-DIVE? So when it comes to publishing, so this is data that is publicly available with the DOI, that is going to like persist on ESS-DIVE into the future. So that data should always be available. And a follow-up question I have to that is, are you also curious about private data, or is your question mostly referencing public data? You feel free to follow up in the chat as well.
I just want to say that this is Charu here. The data are not deleted of ESS-DIVE in general. So all the files are there, and technically as the public data especially are supposed to be there in perpetuity. What perpetuity means is, all is still up for discussion, but in general, we don't delete the data, it's there. And if for whatever reason LVL is not going to host the data, we'll make sure that it's available through other sources, and it is backed up on data one. So data are preserved for the long term. That's as long term as DOE can guarantee us.
Yes, Terry, go ahead.
Hi, thanks, Kim, for your presentation. You mentioned to start with the file level metadata if you're short on time. Is that like the minimal to get your data into the Fusion database? Like if you don't have a data dictionary?
Yeah, so Kim, I can answer that question, but feel free to add in. In order for a data set and the CSV files to be available within the Deep Dive API and parsed by the Fusion database, there must be both a file level metadata file and data dictionary file. And for the CSV files to be parsed by the Fusion database, they do need to follow the CSV reporting format recommendations. But nevertheless, like including a file level metadata file, as Kim suggests, is useful for kind of broad understanding of the data set.
Thanks.
I think the data dictionary is my favorite metadata file. Useful to create it before you collect the data.
Kim, just because there's not a question right now, could you mention maybe why you like it so much? Because I think that's a really good comment.
Yeah, I guess an example is like I was just in the field 2 weeks ago and we were working on some, well, new to me data, and I think it really helped. Well, firstly, defining things like units before a team goes to collect data means that you're all on the same page and you're all collecting the same data, and being very clear on the definitions of all your data columns and everything just ensures that things are harmonized from the beginning and saves any kind of back-end work where you have to kind of either convert things, or if the wrong type of data is recorded in the incorrect column and you need to pass things out again. So I think working on getting a like a style sheet for your data collection kind of arranged before you start collecting the data can really clarify what you are collecting and make sure everyone does it in a consistent way.
Yeah, that's really great. A great way to use the data dictionary file. I feel like communication before going out to the field is really huge.
And then it's all ready to go for the data archive. So it's kind of like multi-purpose.
Yeah. And one less thing to do when you're actually in the field.
Absolutely. So I see there's another question from Morgan about data versioning.
Yeah. Okay. Yeah, Charu, please go ahead.
Yeah, I think this is one thing we've recognized right now, and it would be helpful to understand, Morgan, a little bit more about what you're trying to do. We do provide the timestamp for that particular reason to indicate the latest versions, and it is in our current plans to improve the dataset lifecycle and improve the versioning scheme. But it's not something I think you'll see materially come out in the next, 6 months or so, something like that, in that time frame. But it is in our plans to sort of really think through how people want to version data, and we'd have to sort of do user interviews to see what the needs are, because it's not that straightforward. We archive all the different versions, so we have all copies of everything that's ever been touched, including changes of metadata. So I think that's our problem, is sort of figuring out what is the most useful historical version to surface, because anytime you make a change in the metadata file, that's a new version in our system. But that, so that depends on how many times you edit the metadata. For example, like you could have 30 versions of a particular data set, but you might not want all of that to be surfaced to in a sort of a chain of history versioning system. So there's different possible solutions like tag versions and things like that, but it's not obvious what the clearest path forward is for that. So that's why we're trying to see what are users trying to do with the versioning before we sort of propose a solution. And it would be helpful to hear what you're trying to do.
Sure. Thanks. Yeah, that all makes sense to me. I guess I ask because I do have data stored on other repos, and they usually have some sort of I don't know, panel on the page where you can click back to version, I don't know, 1.0, even though obviously it auto-populates the most recent version. And I've tried to go back and fish out older versions of my own data on ESS-DIVE. And there's not like a quick and easy way to access those older versions.
Yeah, there isn't, partly because of this chain of history of any metadata edit becoming its own version. Now, there's a couple solutions we do ask, recommend in terms of the versioning, and there may be a website link, Dylan, if there's one, you can fish it out and put it on the Zoom chat. But if you really want your version to be permanently stored, what we would recommend is to then create a new version of the dataset as a separate dataset and get a separate DOI for it, so that your older version exists. Because the way ESS-DIVE works is if you're editing a dataset and you're continuing to edit the dataset, then you retain the same DOI. So then that DOI only points to the latest landing page. But if you want your older version to be preserved, then you create a new version, and there's many ways in which we can just help you duplicate the information. That's easy for us to help you with. And then you basically create a copy and you edit from there. Then that way you can then manually tag the different versions, like you can say version 1.0, version, whatever you want to call it, and then you can refer to it. And then we have a related references field where you can go and populate the older version. So we don't have a straightforward linking mechanism, because technically, like, when does it become a new, once it's published, and then the metadata edits or file changes become live instantaneously. So we don't have you sort of go through yet another publication cycle once a data set is public. So all versions are new versions. So it starts to become very tricky at that point to identify what is the right version to surface. So that's why we're asking you to do it manually, so you control what version you feel is like the latest version. Does that make sense?
Definitely makes sense. And having the suggestion to just publish under a completely different DOI is very helpful.
Yeah. And then Dylan just posted the versioning documentation on our website for exactly this sort of use case. So.
Yeah, but I think even things like, if you do have multiple versions in the same data set and having kind of drop down instead of the like following the link back. I think that there may be some UI improvements we could make in the future. So we would be, I think, definitely interested in hearing your feedback in terms of how we could, for the stuff that we do have, how we could make that a little bit more usable and transparent. I think there's, when we kind of are at the point where we're making some of these improvements, there's probably things that we can do to make it simpler just within our existing UI.
Gary, go for it.
Yeah. So I look at this page all the time with the landing page, and I know that there's the version after the data set and the DOI listed there. And I know this updates when I've been working on them, but how would I know this is a different one just by looking at it? I guess it looks like there's a date then timestamp at the end, but you wouldn't know. I mean, if this is out on the landing page, you wouldn't know there was a previous version of this unless it told you somewhere, right?
Yeah, we require you right now to, if you're creating, I'm assuming your question is about creating a new data set with a new DOI. Is that your question, or updating of existing?
This is just me realizing that there's the version with the ESS-DIVE identifier. And I
Yeah.
know that it changes, but I didn't ever think of it as telling me that if I wasn't familiar with what that was,
Yeah.
I wouldn't know that it would ever be different.
Right. And we thought about a number of different naming schemes to make that easier. And then the easiest thing seemed to be, or the most coherent way to do this seemed to be putting the timestamp on it, or the date and timestamp, so you knew exactly what date, when that date was, published and archived. Right now we're just saying if you're editing a data set that you manually tag it with whatever version, we don't have a standardized versioning recommendation scheme for data sets. And that was all part of what we are calling our data set lifecycle. We have a whole sort of set of milestones associated with improving the data set lifecycle. And it's not just versioning. There's sometimes people want to retire data sets, and there's a lot of other aspects to what happens from the start to the end of a data set. So we'll be kind of thinking about it holistically, but for now, if you want like a more human readable version number, it's really up to the person who's contributing the data set to make sure the name of the data set appropriately reflects the versions. And then if you're making changes to your files, then you'd sort of want to go through and make sure your metadata says what's changed or what this version has. So that's the onus is on the contributor to do that. Right now, we don't automatically tag a version number other than updating the date. Again, it's all open for discussion. If there's the community likes a particular, versioning scheme, then we totally consider that. And that's something we hope, something like the data management working group can coordinate and tell us, hey, this would make sense for our community. And Dylan just posted something in the chat that tells you like, what are we recommending you update? Every time you update your data set for the versioning part of it, what should you be updating? So. And yeah, if you see the optional recommendation there, it's about version numbers, and you could do that in your title, you could do that in your files, and there's various ways in which you could do that, but it's not automatic from our side. Does that answer your question, Terry?
It does. We've been working through one just recently that is actually in update, but completely different authors. And so we made a decision to make a new data set and just cross-link them and mention
Yeah,
those.
that is actually a really good use case for creating a completely new data set when the authorship criteria is different. That's definitely, we would strongly recommend you create a new data set in that case. So you only want to update the DOI and retain the old DOI if like most of the metadata is the same and then you're just adding files or making minor changes. But changing authorship we would consider as a major change and would recommend a new data set and do exactly what you did, which is to cross-link the data sets. And we're
I
trying.
will read through here because I can't remember now what we decided about where to put the version or something in the title, or just mention things in the abstract.
Yeah, and we're trying to make it easier to cross-link all of these data sets with related identifiers. So that's something also we're working on. So hopefully some of these things will make it easier for you to find the different versions. It's like we don't have any further questions at this point. Okay.